In this video, we're going to learn how to calculate acceleration if we're given the right amount of information. So remember that acceleration, good start. Acceleration is equal to a change in velocity divided by a change in time. And the way we tell a change in velocity is we say a final velocity minus initial velocity. And then we usually just have one time that's given. So these subscripts here, this F is going to stand for final, like we said in class, and this I here stands for initial. So that's how we get our change in velocity. So we're going to start with the sample on page 328 that says a flower pot falls off a second-story windowsill. The flower pot starts from rest and hits the sidewalk 1.5 seconds later with a velocity of 14 meters per second. And we're going to find the average acceleration of the flower pot. So we read our problem. Now we're going to write our data table. The four things we're interested in here are VI, VF, again, that's initial velocity and final velocity, the acceleration, and the time. So I've got my bare bones there. Let's look in the initial velocity here. It doesn't actually give us a number, but it says the flower pot starts from rest. So that means the initial velocity is 0 meters per second. So you're going to want to look out for something that starts at rest or comes to a stop. Both of those mean a velocity of 0 meters per second. Let's see, it hits the sidewalk 1.5 seconds later. So that's our time. With a velocity of 14.7 meters per second. So that's our final velocity. So that's how we pull the information out of the problem. Then it says find the average acceleration. So that's pretty clearly our question mark. So there's our step 2. We've read the problem. That was step 1. We've written out our data table. That's step 2. Now we want our formula. So that is A equals VF minus VI over T. All right, now we're going to substitute our information. VF is 14.7 meters per second. VI is 0. All of that is over our time, which is 1.5 seconds. So you'll take your calculator and you'll say 14.7 divided by 1.5, and you get 9.8. And now we need to deal with the unit, right? You might think the seconds cancel out, but they don't. Look at this compound fraction that we have. We have a meters per second upstairs and we have a second downstairs. They don't cancel. So what we have, you have two options of writing this. You could say 9.8 meters per second, because as we talked about in class, acceleration describes how fast something speeds up or slows down. So if we write it this way, what we're saying is every second, the speed of this flower pot is increasing by 9.8 meters per second. So it's speeding up at a rate of 9.8 meters per second every second. So that's really the definition of acceleration. But as we said in class, sometimes it's easier to just write meters per second squared. And there's really no meaning to a square second. And that's why when we teach it, we like to keep it as meters per second. But you will see it in your book as meters per second squared. Now, before I let you go on to the rest of your practice, let's map out these formulas again, just in case you didn't get them in your notebook. So we start out with acceleration equals VF minus VI over T. What if we're asked for T? Well, you can do the algebra on your own if you want, or you can ask for help. We'll show you how to do it, or you don't have to do it at all. You can just write down VF minus VI over A. And then finally, if we ask you for VF, if you multiply both sides of equation number 1 by T, and then add VI to both sides, you get VI plus AT. So there's the three formulas there. We won't ever ask you for VI, so I didn't solve for that. So make sure you have those three written down before you start working the rest of those problems on 328. And for those of you in CP, moving on to page 857 as well. So as always, if you have questions, let us know. Good luck.